Today we're beginning Chapter 1, which includes an introduction to statistics. In this recording, we'll take a look at sections 1-1 and 1-2. 1-1 is merely a review and a preview, and in this section we basically have one learning outcome. At this end of this section, actually at the end of section 1-2, the student will be able to define sample, population, and census. So we begin with some basic vocabulary. We have, first of all, data or data, can be pronounced either way, observations that have been collected. Statistics can be thought of as a collection of methods for planning experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. And we'll do a number of experiments where we'll collect data in the classroom. Population is a complete collection of all elements to be studied. So, for example, if we're concerned about studying, and I like to use Venn diagrams for this if I can get my pen here to work. See if I can get my pen to work. I like to think of a population. If you ever studied set theory, the population is the universal set. So, for example, we may decide we want to study the students at Germanic Community College. That would be our universal set. And then we may select some subset, which is typically referred, and I'll just refer to it as A here, that is a subcollection of the entire population. That's called a sample. So if we're thinking in the, and I'm a very visual learner, so the universal set is like the population, and the subset is the sample. So basically what we do in statistics is we collect information from a sample, and we want to somehow use that information to draw conclusions about the population we're studying. Now, a census is where we collect data from every member of the population. So in that case, we would be collecting data from everyone in the universal set if we wanted to do a census. And the government tries to do a census every 10 years, collecting information from every household. So that's an example of a census. Now, what you'll find in the Triola text is that the first section of every chapter is just a review and a preview, and there's no homework attached to that. So it's usually a very short section. But when you start with the second section of the chapters, you'll find that there is information in here that you will have to know for your homework and quizzes and so forth. So we're starting in 1-2, think about statistical thinking. And critical thinking is extremely important when we talk about statistics. You begin with statistics simply reading some information, maybe in the newspaper. You may see information online, presented to you online on different sites. You may hear information on the radio, or perhaps see it on TV. And you need to be able to sort out that information and make a decision as to whether you think the information is valid or not. So what we're trying to do in Chapter 1 is to begin to think statistically, so that we are critically thinking about the information presented to us, and we're deciding whether or not that information is something that we should pay attention to, or whether it's biased and not really something that we need to consider. So when we're working with statistical data, you should apply certain basic principles of statistical thinking. And the first part is to prepare. You want to know something about the context of the data. Where did it come from? Was it a sample taken at a single college and they're drawing conclusions about all colleges? Was it a sample taken from select few colleges, perhaps the Ivy League colleges? Was it data that was collected from a random sampling of colleges throughout the United States? So we want to know the context of the data. Next, we want to know who collected the data. What is the source of the data? Is that person or group likely to be biased? So if we're getting statistical information on some product, some cleaner that they're trying to sell on TV, and they're presenting the data that they collected, would have reason to question that, because it's very likely that it could be biased in some way. We also want to know what sampling method was used. Was it a convenience sample where they simply interviewed people who were convenient, like family members and friends? Or was the sampling method random? And that's what we're shooting for in statistics, is to have a truly random sample so that we try to eliminate the possibility of bias. We want to look and see if we can determine any problems with the collection method. And so one of the labs you'll be doing in the early weeks of the course deals with the experiment design and the method of sampling. You're looking at that to consider if there's any bias built into the method. So that's the first part, and that's basically what we're doing in Chapter 1. We're talking about how to prepare, that is. Where did the data come from? What's the source of the data? What's the sampling method? Then when we get into Chapter 2, we talk about graphing the data, and we want to analyze the data we've collected. We want to look at a picture of the data if we can. That would give us a graph. We want to explore the data. Are there any outliers? How is the data distributed? What are the important statistics that summarize the data? And that actually takes us into Chapter 3 when we talk about the statistics that summarize the data. And then as we get into the later part of the course, the end of the course, we'll begin to draw conclusions. Are the conclusions justified by the statistical analysis? We'll actually do this. We'll have data and we'll draw conclusions based on our statistical analysis. And finally, practical implications. Sometimes something may be statistically significant and it may not be practically significant, and we'll see what the difference between those two ideas is. Now, statistical thinking involves using common sense more than a set of formulas. So what we want to do is get practical. We want to think critically, use our common sense, and then we'll be ready for statistics. So we begin with a discussion of what is called a voluntary response sample. A voluntary response sample is a sample where the respondents themselves decide whether to be included. And typically this is a poor way to collect data. At one time on TV they had 900 numbers where you called in with your opinion. Now they have online surveys where you can choose to participate or not participate. And Germana uses a voluntary response sample to collect student evaluation data, which is really a very poor way to do it, but actually the college is limited in terms of means to do a collection of the student evaluation data. So those with moderate viewpoints tend not to respond. What you end up getting is the extreme the people who have extreme values and or extreme opinions on the particular subject at hand. So potential problems if you don't take the measurements yourself, like if you're asking people what their height and weight are, they tend to give inaccurate measures, so it's better to have a measuring tape and a set of scales so that you can actually weigh them and measure their height rather. Number two, you want to be careful not to use too small a sample. If your sample is too small, you may actually not get enough information. You want to be careful how you word a question. You don't want to tell the respondent how you want them to respond. For example, I've gotten these phone surveys where the question was worded such that you would only respond in one way, that is the way they want you to respond. Let's see, you believe in government waste, in eliminating government waste the way so-and-so does, correct? And that tends to lead you in one direction. The order of the questions and their possible answers can result in skewed results. One thing that's been noticed is that sometimes people just go through and mark the first choice, so that can make a difference. Too many non-responses can skew your results. Very often when I'm eating dinner and they call trying to take a survey, I just hang up. So if you get a lot of those, it may skew your results. If you're missing some of the data, that can affect your results. If you miss a certain segment of the population, for example, in your sample. Precise numbers tend to be inaccurate. If you're estimating how many are in a crowd, you want to use perhaps hundreds or thousands as opposed to being exact, like 2,347,561. Probably it would be 2,300,000 approximately would be a better way to say it. Some studies cite missing or unclear percentages, so you want to make sure people understand how your percentages are calculated.